Alright team, 7C. This is your first exercise that you should be trying to focus on from chapter 7. It really is where the theory starts. D is the reverse. So you just got to learn C first before you do D. Yeah? Here we go. I've got a graph of y equals to 1 on x squared. Reminder, that's a truncus function. Okay? What we're going to do is we want to know what would I write as a new equation so that this graph will follow these transformation or sequence of transformations. Okay? So if I use Desmos for now, let's find a Desmos sheet of paper. Desmos. Here we go. So this is what we have. We have y equals 1 on x squared. This is what it looks like. Okay, that's your truncus function. What we want to do is we want to follow these sets of transformations. We want it to reflect in the x-axis, dilation of factor 2 from the y-axis, translation 2 units to the left, dilation of factor 1/3 from the y-axis in that particular order. Okay? So what would the new equation be? That's the skill that you're building from exercise 7C. The first part of the skill is that you need to be able to understand what this sequence of transformations mean. Right? That's what I was teaching you in part of the tables yesterday. And then put it into what we call a mapping notation. It's going to be that mapping notation allows you to work algebraically to get to that final equation. Okay? So let's recap on our understanding again. When we say reflection, what does that really mean? What's the other word for it that we all can understand? What's reflection mean? Starting with F. Flip. Okay, so now you can either flip vertically or you can flip horizontally. So when they say reflection in the x-axis, that tells you where the mirror is. So they're saying on the x-axis, if you picture it, there's a mirror. So for every coordinate here, it's going to flip across. Now this is clearly a vertical flip. So what do we do to every xy coordinate? How do we show there's going to be a reflection that is a flip, vertical? A vertical flip. How do we do that from yesterday's lesson? Anyone remember? Sion?
Negative x.
Not negative x. That's the confusion one. So it's on the x-axis, yes. But notice if you pictured a point, so I'll draw it on the screen. Oops. I'll draw it on the screen. You got to picture where the mirror is. So if the mirror is horizontal, that's the x-axis, right? Pick a point. Doesn't matter which point. But if you had to draw a reflection to that, just imagine if there was a reflection to it. Where would it look? Well, it will look like that, true? Because that's the mirror image. But what you're doing here is you're flipping from the top down to the bottom. So it's actually going from a positive y value to a negative y value. That's called a vertical flip. So the only way that you're going to have a positive to a negative y is you put the negative not on the x, but on the y. But a lot of students do that confusion because we have the word x-axis. So be careful with that. Try to picture what it actually is happening. So here, good attempt just now, but it's actually a negative y. That's what the first step means. So you picture a mirror on the x-axis. Where would the reflection be? Is it flipping vertically or is it flipping horizontally? Anything to do with vertical is your y values. Anything's horizontal is your x values. Okay? Let's try the next description. Dilation. What's another word for dilation? Starting with S. Stretch. It's a stretch. Okay, so you're stretching. Now you're taking technically it's not stretching the graph, it's actually stretching the number line, but I don't want to confuse you there. So just think of it as stretch. And you're stretching it by a factor of 2. That means you're doubling. Now we know that factor 2 just means double. We're stretching this graph, or technically the number line. But when it says from, that's a key word there, from the y-axis. And the way I taught it yesterday was try to move your hand and visualize what that looks like. From, so y-axis is the vertical line, and you're moving your hand away from. So if you have to move away from, which axis am I moving in? What kind of stretch is this? Is it a horizontal stretch or vertical stretch? Horizontal, because I'm moving away from the vertical line, right? So if it's a horizontal stretch, which coordinates am I affecting? Is it the x or is it the y? Is the x, because anything that's horizontal is your x coordinate. So when we say dilation of factor 2, what you're really saying is double horizontally, which means double the x coordinates. That's what the second line means. Okay, so this is the first skill in exercise 7C, is to be able to interpret what these sequence of transformations mean. Next one. Then there's a translation of 2 units to the left. Okay, now if I'm moving, see, I need you to focus, yeah? So when I'm moving left, that is very obvious. Is it a horizontal movement or is it a vertical movement? Horizontal, so which one should it affect? Is it the x coordinate or the y coordinate? The x. Okay, so when I'm moving left or right, it's either add or subtract. But if I'm moving left, I must be subtracting. So I must be subtracting by 2. So this now gives me the x transformation 2x minus 2 so far. And then again, I've got another dilation, which we know that means the stretch. So I either stretch vertically or I stretch horizontally. Here it says a factor of a third. So a third just means instead of tripling it, you're compressing it, you're making it smaller. Yeah, so instead of stretching it out by 3, then you're kind of compressing it by a third. So here, dilation of factor of a third from the y-axis. But from the y-axis, which direction am I moving? Think about the y-axis. If I'm moving away from, so where am I multiplying this to now? Good. It's the x. See, it's a horizontal stretch again. So I actually gave you 2 horizontal stretches there because I wanted you to think about that. Right? So what am I really saying here is you've got a negative y, but I'm multiplying this now all by an extra third. Can you see that? I'm multiplying it all by a third. So if I rewrite it again, you've got x, y maps to 1/3 times the 2x minus 2. Now if you multiply that, 1/3 times the 2x, because we're expanding the brackets, 1/3 times 2x gives me 2/3 of x, and then 1/3 multiplied to negative 2 gives me minus 2 over 3. This is what I obviously tried to make it more complicated so that you can see how we can play around with the sequence here. Okay, so just read. Normally in your textbook they won't do this. They'll probably say x-axis instead. But I'm trying to show you just follow what the sequence says. Now that we got this here, whatever you see this transformation here is, that is describing exactly what you want up here. Okay? Once you're able to do that, that's the first skill, that you can read mapping notation. The second skill is to make this and change the equation so you get a new equation. So how do you do it? Here's the technique I taught you yesterday. So the notation is you got your original x, original y, or think of it as old x, old y. This, after these sequence of transformations, it gives you the new x coordinate, which we call x dash. This will give us the new y coordinate, which we call y dash. So yesterday's technique I taught you, that means new x must equal to this. This is what I'm doing to the old x. I'm doing 2/3 of the old x and then minus 2/3. So write it out as an equation. Here we go, I'll write it out. New x equals 2/3 of x minus 2/3. Whereas on this side, new y is equal to negative of original y. Okay? All right. What is the technique? Our goal is to replace the old equation. So this is old x, old y. If you want to replace it, well, I need to know what old x and old y equals to. Your job here is now to rearrange the equation to find out what does old y and old x equal to. So here you're just using a bit of algebra, moving things across. I would say add 2/3 on both sides. So add 2/3, add 2/3. 2/3 take away 2/3, cancels out. You get now x, new x, plus 2/3 is equal to 2/3 of x. Our goal is still to find x. How do you get rid of the 2/3? There's a lot of ways, but for me the most obvious is if you times it by 3 on 2. 3 and 3's cancel out, 2 and 2 will cancel out. So whatever you do to one side, you do to the other, yeah? So I times this right side by 3 over 2, and on the left, I will also times it by 3 over 2. Be careful, there are two terms there, so when you multiply 3 and 2, you should go to both of them. So if you multiply it, what do we get? 3 over 2 times x, new x is 3 over 2 new x, plus 3 over 2 times 2 on 3 happens to give me 1. These cancel out, and you get original x. Okay, so there's just a bit of fractions, because the way I sort of did it at the end, I added a bit of fractions for you there, but you have to be a bit more comfortable with that. So this is what original x equals to. Original x will equal to 3 over 2 times new x plus 1. Conveniently, the next one is a bit easier. If you want to know what original y equals to, times both sides by -1, or you can divide both sides by -1. So I'd say times by -1 times by -1, and you get negative y dash is equal to original y, or old y. That arguably is the hardest step that you would do in exercise 7C. Okay, it's just that rearrangement. So as long as your algebra is good, then we're good. But the first step was to get your sequence. You get your sequence wrong, you get the whole thing wrong. So you got to get sequence right first from the mapping notation, and then you rearrange to get old x, old y. Now we can replace the equation. Old y can be replaced here. What is old y equal to? Old y is equal to new y with a negative. So I rewrite it. It's now new y with a negative is equal to 1 over, now instead of x squared, that's your original x. So the original x is equal to 3 over 2 new x plus 1. So I replace that, and I write, okay, well then that's 3 over 2 new x plus 1. We normally write the equation with y, not negative y. So here, we have to times it by -1, and then I have to times this by -1, just so that these negatives cancel out. And you get new y equals to -1 all over 3 over 2 new x plus 1 squared. Now you can see how I would have taught you back in chapter 4. So even if you didn't know all of this technique, you still would have been able to sketch this graph. You would have saw the negative, so you knew it's a truncus function, but it's flipped, okay, which we knew. We already said reflection before, so it had to flip. Here, see, most students won't know how to tell if it's moving left or right. Okay, here, if you use the technique I taught you in chapter 4, this is what I taught you in chapter 4. I said, let this equal to 0. And if you let it equal to 0 and solve for x, can you see -1 on both sides? So you get -1, 3 over 2, x dash, times 2 to the -1, you get 3, new x equals -2, and then divide both sides by 3, you get move to the left by 2/3. Now, why is that the case? How do we know? Well, yes, at the start I said move, where is it again? I said move to the left by 2. But then I said followed by a compression horizontally by 1/3. That's why overall, instead of moving over by 2, it's to the left by 2, but compressed by 1/3, which makes sense. Okay, so that's why the technique I showed you will work. And the reason why it works is because instead of giving you 0, well, I was meant to teach you x and x dash. That would have been confusing at the time, so I just told you to write it equal to 0. Because all you're really doing is you're moving from here back to here. That's what you're really doing. Okay, that minus 2/3 is that. And by letting it equal 0, you ignore that bit. That's what I was doing. Okay? Anyways, I'm going to pause the video. I want you to have a go with the next one. The next one should be easier. So this time I should have given you Yeah, it would have given you two different things, yeah. Try this one. Tell me the new equation for root of x. Okay, so I'm going to pause the video. So here we go. The next step was you should have new x is equal to negative 2x plus 6. And if I rearranged all that to find old x, so that's what? X dash minus 6 all divided by negative 2 gives you original x. If you split that up, that's really just negative half of x dash plus 3. All I did was I just split the fraction up. Okay, so I just did negative 6 divided by negative 2 is 3, and then 1 divided by negative 2 is negative half x dash. You split up the fraction. If you want me to take another step, I'll show you what I did there. All I did was I split it up and I wrote x dash on negative 2 minus 6 on negative 2. That's what I did. And that's how I got plus 3 and negative half x dash. Next one is y dash. You should have got y dash is equal to y plus 2. So original y must equal to y dash minus 2. Hands up if you got the second step correct. So far so good. Okay, so those are the next two. So if you got x, you got y, you can replace them now. Old y is now replaced with new y minus 2 is equal to the square root of old x is equal to negative half of new x plus 3. Once you substitute it, you never leave just y minus 2. You always write it as y equals to something. This is one of the reasons why the y transformation doesn't look like the opposite. So it was plus 2, became minus 2, but then over here, I plus 2 again. That's why it feels like the y's don't change, but the x's do. So you got negative half times the x transformation plus 3 plus 2. Hands up if you got this as your equation for the transformation. Beautiful, that's 7C. Okay, so 7C goes from the first step, mapping notation, and that allows you to know what the new equation should be. Over time, you don't have to do the mapping notation, you can do it by inspection. You start to be able to read it. So you'll be able to read 2 units up, so that's why it's plus 2. 3 units left, that's why it's that plus 3 there. Dilation of factor 2 from the y-axis actually ends up being the reciprocal, so it becomes 1 over 2 rather than just 2. And then reflection of the y-axis, you know it's negative on the x. So over time you can just read it from sequence to equation. Yeah, same thing. All right. Any questions? That's 7C, so I need that core that you need to be able to do that. For those who feel pretty confident, can you please grab now exercise 7D? I'm going to go through the notes for it so that we're going backwards. And then those are the two that I want you to master. Okay, those are the two key skills. 7E applies. So you use 7E essentially to sketch, but you need to know those two skills. C and D are your bread and butter of chapter 7. All right? Here we go. Let's have a look. I'm going to stop the video.